Alright, if you guys could please turn to 7.7, solve right triangles. To solve a right triangle is to find the measures of all its sides and angles. So if you're given a problem and it says solve the right triangle, you should be getting more than one answer. You're not just looking for one side or one angle. You're looking for all the sides and all the angles. Alright? Okay, inverse trig functions are pretty much just the opposite of trig functions. You can read this over. We're going to do some examples of what this means. Okay. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. Okay, so this is what we're looking for. We are looking for angle A. We are given the opposite side and the adjacent side. So if you think of SOHCAHTOA, we have opposite and adjacent, so we're going to be using tangent. Now, tangent of A equals 16 over 20. 16 over 20, if you divide top and bottom by 4, you get 4 over 5. 4 over 5, if you were to put it in a calculator, actually, let's go ahead and do that. 0.8. Okay? I'm going to add a step in here. This is what we have. Tangent of A equals 0.8. But I don't want tangent of A, I want A. So how do I get rid of tangent? This is what you do. You're going to take inverse tangent of both sides. Inverse tangent cancels out the tangent, and now all you're left with is A. So you just have to find inverse tangent of 0.8. Let's go ahead and do that. Okay. So, the way you find inverse tangent on your calculator, you're going to hit second and tangent. You should get a little tangent with a -1 sign. Inverse tangent of 0.8. 38.65, and actually they just want to the 10th, so .7. Okay, and you could actually write this the measure of angle A. That's the proper way to write it. Okay, this is what we're going to be doing. It's kind of confusing the way they write it out, so I wanted to write it out this way. Okay, inverse tangent of 0.8 equals the measure of angle A. Using a calculator, inverse tangent of 0.8, and I'll give you the whole decimal of what it says on this calculator. 38.65980.825, etc. Okay, so the measure of angle A is approximately 38.7 degrees. Alright? Okay, you guys try this one. Let's go on to page 2. Let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measures of angle A and angle B to the nearest tenth of a degree. Okay, so sine of A. The way you get rid of sine is with inverse sine. That cancels that out. So the measure of angle A is the inverse sine of 0.76. It turned off again. Okay. So, second sine, that should give you the inverse sine, 0.76. Alright, 49.5. We're going to do the same thing here. Inverse cosine, inverse cosine. That cancels out, so the measure of angle B is inverse cosine of 0.17. Second cosine, should get inverse cosine, 0.17. 80.2. degrees. Alright? Okay, solve a right triangle. Solve the right triangle. Round and decimal answers to the nearest tenth. Okay, find the measure of angle B. That's this one. Using the triangle sum theorem. So, we know that this is 90 degrees. This is 23 degrees. So this has to be whatever would make it add up to 180. Okay, now if you were to add these together and subtract, I'm pretty confident you guys can do that. You would end up with 67 degrees. Okay, now I'm going to use this angle for my trig function. You actually could use this one if you wanted, but I think in this problem, the example they're giving, they kind of want you to use this angle. I'm going to approximate BC using, well, let's see. This is the opposite side. The only side we're given is the hypotenuse. If you think SOHCAHTOA, opposite and hypotenuse, we're going to use sine. So we're going to approximate BC using a sine ratio. So sine of 23 equals BC over 40, opposite over hypotenuse. This is the ratio for sine of 23 degrees. I'm going to multiply each side by 40. So 40 times sine of 23. I'm going to approximate sine of 23 degrees. 40 times, let's find out. Alright. Sine of 23. Try that again. Sine of 23. Okay. 0.3907. Times 40. 15.6. So that's BC. Okay? Now let's look at AC. AC is the adjacent side. So, adjacent side, and we're given the hypotenuse. Adjacent hypotenuse, we're going to use cosine here. So, approximate AC using a cosine ratio. Cosine of 23 degrees. AC over 40. So that's writing the ratio for cosine of 23. I'm going to multiply each side by 40. So I've got 40 times cosine of 23. I'm going to approximate, cosine of 23 degrees. There we go. Alright. So now I have 40 times 0.9205 times 40, 36.8. Okay, so the angle measures are 23 degrees, 67 degrees, and 90 degrees. The side lengths are 40 feet, about 15.6 feet, and about 36.8 feet. We have solved for all three angles and all three sides, so we have solved the triangle. These problems where you are solving a right triangle, they are going to be longer problems. Multi-step, longer problems. Okay, so just a heads up. Alright, let's go on to the last page. You are building a track for a model train. You want the track to incline from the first level to the second level 4 inches higher in 96 inches. Is the angle of elevation less than 3 degrees? Alright, so this is the situation. We're looking for this angle here. We have the opposite, and we have the adjacent. So if you think SOHCAHTOA, opposite and adjacent, that would be tangent. So tangent of x, opposite over adjacent, the opposite side is 4 inches, the adjacent side is 96. Excuse me. 4 divided by 96. Alright. So x is approximately, let's see here. I'm going to add a step in here, just in case somebody's confused. Tangent of x equals 0.0417. Okay? But we're not looking for tangent of x, we're looking for x. So I've got to take the inverse tangent of both sides. So x is inverse tangent of 0.0417. Let's pull out my other calculator, which is probably turned off. Of course it has. Alright. Okay. Inverse tangent 0.0417. It's approximately 2.4 degrees. The incline is about 2.4 degrees, so it is less than 3 degrees. Alright, I'll let you guys do the checkpoint, and that's all.